So welcome to the session 3 of unit 4, construction of CNC machines and a computer integrated manufacturing. So in the last class we discussed about the different types of loads. One was a static load, dynamic load and thermal load. So let us discuss what are the factors to reduce the thermal loads. How to reduce the heat source in CNC machines. By mounting the motors and transmission systems externally, if you mount it outside, so that the heat will be dissipated to the environment easily, so you can reduce the thermal loads. By designing the proper coolant system, this is very important. So the cooling of workpiece and the cooling of machine tools and cooling of the entire CNC machine is very important. Next is by proper lubrication for bearings and guideways, placing the headstock motor externally so that thermal loads are equally distributed in all the directions. So how to reduce this heat one source is proper lubrications. Lubrication will carry away the heat generated in the machine tools. So in this sketch you can see the coolants have been passed, so the heat between the cutting tool and the workpiece is reduced. So the coolants are continuously passed the machine itself, the entire inside temperature will be equally distributed. So this is one type of thing. So we saw about, so these are some of the sources to reduce, and major cases is that you have to mount the motors outside the machine tools. Next is guideways. Guideways are the machine elements containing slots in which carriage or table will travel. So here you can see the different guideways here. So on which the tool, on which the tailstocks are mounted and the drives are mounted, and it is going to move from towards the left and right along x-axis, y-axis and z-axis respectively. So this is all about this guideways. The guideways surfaces should be accurately machined so that the surface should smoothly slide. So this sliding accuracy matters a lot for the accuracy of the final finished components. So there are first kind of frictional guideways. Generally we will have two types of guideways. One is frictional guideways, second one is anti-frictional guideways. What is frictional guideways? These frictional guideways are adopted in conventional machines. These are some kinds of used in conventional machines. They operate under sliding friction. They don't have constant coefficient of friction. So there is a complete sliding between this, and they have a surface to surface contact in this case. The coefficient of friction is high at starting, and as the movement speed increases it falls rapidly. Means the coefficient of friction is high at starting point, and over the speed increases the coefficient of friction will reduce. So next is in the frictional guideways, a start of moment of force required to overcome the friction must be high. So initial force should be very high in order to overcome the friction, moment of inertia, and high forces results in deformation of driving mechanism. When you increase this force, what happens? There is a deformation in driving mechanisms. So due to this increase, what happens? They cause a slip, and it causes a slide to slip and move to faster rate repetition for their cycles. So the position errors and jerky motions results in slip phenomenon. So when there is a jerky motion, there is the chances are there it results in a position errors. So that is why the surfaces should be accurately machined. If it is not machined, it results in a stick slip phenomenon. Stick slip phenomenon. It is a jerky motion between the slide and a carriage or a tool post. So to reduce this, the minimum and constant coefficient of friction should be maintained. If the coefficient of friction is not uniform, then this type of defects are caused. Then this type of problems will arise. So in order to do that, the surface should be accurately machined so that the minimum and constant coefficient of friction should be maintained. So once you maintain the constant and minimum coefficient of friction, so the frictional forces will be reduced. Frictional guideways are used due to following advantages. Why frictional guideways are used in all CNC machines today? In conventional machines and CNC machines, we find this type of guideways. Why? Because it is easy to manufacture. Generally, the casting process is carried out. Cast irons are huge, so it is easy to manufacture. It is cheaper. The cast iron is very cheaper, and it can be easily manufactured and can be affordable by any industries. Due to more surface contact surface, it transmits more load. More surface contact, more transmission of more load. Good damping capabilities. Damping capabilities means it can withstand more vibrations in this case. Low manufacturing cost. The cost for manufacturing is very low. So this is all about the frictional guideways is concerned. For these are the important advantages which leads to go for the frictional guideways in CNC machine. Dear students, thanks you so much for your patience listening on a session. 3 of Unit 4 Constructions of CNC Machine. Thank you.